Unit 3 is all about bonding, how bonds happen, what happens with the electrons, and how we name those things. So the first type of bonding that we're going to talk about is ionic bonding. So it helps at this point to have a little bit of a recap about just exactly what an ion is. An ion is an atom with a charge. So the real question is, how does an atom become charged? Well, an atom becomes charged by gaining or losing valence electrons. And remember, valence electrons are the outermost electrons. So there's two different things that can happen. First thing that can happen is you can lose a valence electron. So this diagram over here on the right is a picture of what element? I'll give you a minute to try and figure that out. Hopefully you were able to figure out that this element right here is sodium. We know it's sodium because there are 11 electrons. Now, when we do this, or look at this Bohr model right here of sodium, we note that there are 2 in the first energy level, 8 in the second energy level, and then there is a single lone electron that makes up the third energy level. Sodium will donate or give away this one electron, and that electron will go away. The result, though, is that sodium will have 11 protons and only 10 electrons. Because the 10 electrons are not enough to balance out the charge, sodium will take an overall charge of +1. And this is what we call a cation. To name a cation, you simply name it according to what the element is. So this is just going to be the sodium ion. This chart right here shows a range or just a depiction of how the different cations are formed. All of the group 1A elements, as part of the periodic table down here, have one valence electron. Therefore, they will only be able to lose one valence electron and will take a +1 charge. The alkaline earth metals, group 2A, have 2 valence electrons, and they will lose both, take a +2. And we go on, so forth and so on, throughout the columns. Now, the final thing over here at the right is just depicting the noble gases, and these do not have any valence electrons that tend to be lost. The opposite end of the spectrum is not the anion, or is not the cation, but is the anion. Anions gain valence electrons. Now in this particular case, we have 9 protons and 9 electrons. So what element is this? Hopefully you were able to come up with fluorine. Now fluorine's a different situation. Fluorine has very close to what's called an octet. An octet would be having 8 electrons in the valence shell, the outermost shell. And as we go around and we look at this here, we find that fluorine has 7 valence electrons. Every element wants to get to that 8, and there is one spot available for fluorine to gain an electron. Because of this, fluorine will gain one more valence electron and will take a charge of -1. Now, anions are named a little bit differently. So we're going to take the end of the name of the element and we're going to drop that ending and replace it with IDE. So F-1 is called fluoride. Right here is a list of the common anions and how they run across. Hydrogen, mentioned over here, can be a +1 or a -1 depending on the context. Typically, though, hydrogen will take a positive charge. A chemical bond is the force that holds 2 or more atoms together. We will discuss throughout this unit 3 different types of chemical bond: ionic, covalent, and metallic. all of them involve the interaction of the valence or the outermost electrons. Here's a chart of just common ionic charges. As we talked about earlier, group 1A is plus 1, 2A plus 2, 3A plus 3. Group 4A typically does not take much of a charge. These tend to be more of our covalently bonded ones, which we'll talk about later. And then from there we work our way down. 5A is minus 3, 6A, oxygen's group, is minus 2, and the halogens are minus 1. We'll discuss this middle section in a minute. These are your transition metals, and these have variable charges. All right, so let's talk a little bit more specifically about an ionic bond. The ionic bond is an electrostatic force. Now, that's just a really complicated way of saying opposite charges that holds them together. Now, the biggest thing to remember about an ionic bond is we're talking about a transfer of electrons. So over here, the picture at the right, we have sodium and we have chlorine. Now sodium, again, we talked about it before, has one valence electron. If sodium loses that one valence electron, its new valence shell becomes the second energy level, which is completely full, which makes it more stable. Chlorine, on the other hand, has 1, 2, 3, 4, 5, 6, 7 valence electrons. If it gains one more valence electron, it will reach its magic number of 8. So when sodium and chlorine get around each other, the one valence electron from sodium is transferred to chlorine. In the process, sodium takes a positive 1 charge. Chlorine takes a negative 1 charge. Because a positive 1 and a negative 1 attract to each other, an ionic bond is formed. Pictures down here in the lower left and the lower right are just depictions of different ionic compounds. Finally, the last thing that we're going to address, which will go quite a bit towards our naming, is binary compounds versus ternary compounds. Now, a binary compound only has two different parts. Two parts. You have your cation and you have your anion. A ternary is more than 2, so it's 2 plus. And typically this involves something that we're going to talk about down the road called a polyatomic ion. Polyatomic ions are simply clusters of atoms together that form one overall charge. One example would be CO3 with a negative 2 charge. We'll talk more about this later.